Hello, good morning, and welcome to our math lesson live on KU TV, Elimu Live. Today we'll be covering mathematics. This is a Form 2 topic, equations of straight lines. We'll be live on Facebook and YouTube. So the topic, as I've said, it's equations of straight line. Equations of straight lines. I always advise my students to specialize on topics. This is one of the topics that you can specialize on and where you can get 100%. So when you have a question, you get 100 out of 100. So today I want us to confirm that you can get that 100 out of 100, or else you can say that this topic is a stronghold. Maybe it's just a neutral ground to you. I want us to make it a stronghold. And when you have questions, this topic is brought in paper 1. It can be brought in the section 1 of the section A of the paper 1 or section B. So when we think about section B, it's 10 marks. So should you be able to understand the concept in this topic, you can get all of them. So let me guide you as we explore this topic. This topic has two main areas. If you can be able to work on those two areas, then it will be very easy for you to continue working on other minor areas in this topic. And these areas are these. Number 1, gradient. Gradient. Do you know what gradient is? Well, this is the steepness of a slope. Gradient is also referred to as a slope. Remember, we are talking about straight lines. And when you talk about straight lines, they don't just occur anyhow. Straight lines, we can understand the concept of straight lines with the help of one thing. The X and the Y axis. So you have your X and you have your Y. And as you can see, in most cases you find the straight lines being labeled A, B, and where A you have been given some coordinates. So these coordinates are derived from these axes. Let's say you have your 1, 2, 3, 4 on your Y axis, and then you have the same on the X axis. So when you have a line, this line can be labeled in a certain form. For example, you have said this is 1, 2, 3, 4, 1, 2, 3, 4, negative 1, negative 2, negative 3, and so on. Negative 1, negative 2, negative 3, like that. So this straight line can be said to have a point A on 1, 1. That is the coordinate of point A. And then the coordinate of point B, it is 4, 4. So always remember, when you see a statement, about a straight line where you have been given coordinates, remember that these coordinates are derived from these y and x axes. Therefore, what is gradient? Gradient is the steepness of a slope. How do you find gradient? When you know how to find gradient, well, it will be very easy for you to work on this topic. Then the second main area, the second one, or let me write here, it is the equation of straight line. Equation of straight line. When we think about equation of straight line, this is, let me talk about an equation. Yes, an equation refers to a relation between two expressions. Well, you do have two expressions. They are being equated using an equal sign. So when you understand about these two main areas, then it can be simple. It can be easy for you to think about other simpler areas or other minor areas, like point of intersection of two straight lines. You can also think about the y and x intercept. It would be hard for you to work on this if you don't know about the gradient, about the equation of a straight line. Therefore, you can, when you have those basics, you can be able to finish up this. Number 3, relationship between two perpendicular or two parallel lines, between two parallel lines and between perpendicular lines. So those are some of the areas which you can be able to explore when you have the basics. What is gradient? How do you find gradient? What is an equation of a straight line, and how to find the equation? So let's find the gradient of a straight line. Okay, the gradient of a straight line. In fact, we'll use these coordinates here. We'll use these coordinates A and B, where A is 1, 1 and B is 4, 4. For you to find the gradient, it is basically you having the difference in the y coordinates to that of the x coordinates. So we say gradient equals to the change in y coordinates all over the change in x coordinates. So you can say the change is the difference between the two coordinates. The difference. Now, what are our y coordinates? It's 1 and 4. Then you find the difference between 1 and 4. That is the change in y coordinates. So you can take 4 minus 1 all over 4 minus 1. What is 4 minus 1? It is 3. What is 4 minus 1? It's 3. And therefore, you can say that the gradient of this line here is 3 over 3, which equals to 1. So that is just but an example of how to find the gradient. So we can explore on this by doing further examples. You are told, find the gradient of a straight line. Find the gradient of a straight line joining the points P and Q. So the points P and Q are as follows. So you have 2 points, P given as -4, 5, and Q which is 4, 17. So how do you find the gradient? So find the gradient. Find the gradient. So we have said gradient is equals to the change in the y coordinates to the change in the x coordinates. The change in the y coordinates to the change in the x coordinates. So we do this by finding the difference between these two values in the y coordinates and between the values in the x coordinates. Okay? Therefore, what is 17 minus 5? That is the difference in the y coordinates to the x coordinates, which is 4 minus -4. So what is 17 minus 5, Lana? 17 minus 5 equals to 12. What is 4 minus -4? This is integers. So 4 minus -4 equals to 4 plus 4. Therefore, you have 12 all over 8. It's always necessary to simplify your final answer. So you simplify this to 6 over 4, which equals to 3 over 2. So you can say that the gradient of this straight line equals to 3 all over 2. Another example here. Find the gradient of the point. So find the gradient of the point A and B, where A equals to 6, 1. A equals to 6, 1. You have A, 6, 1, and B 0, 3. So gradient here again, we have said it is the change in the y coordinate. Gradient equals to change in y coordinates to the change in x coordinates. You can see the coordinates there, 6, 1, and 0, 3. On the x, you have 6. On y, you have 1. On the x, you have 0. On the y, you have 3. So the change in y coordinates, remember we have said it's the difference between these two coordinates. Let's take this minus that. So here we have 1 minus 3. So y minus y here. So we can say this is y1 minus y2. So 1 minus 3 all over 6 minus 0. So 6 minus 0. So what is 1 minus 3? What is 1 minus 3? Think of it. It is -2 all over 6. So we can say that the gradient of this line is -1/3. When you have simplified -2 over 6, you get -1/3. So try out this. I hope you do have a pen and a paper or a pen and a book. Yes, don't just listen. It's always good to write examples and try to solve questions given. Therefore, you'll try a question. Find the gradient of a straight line whose coordinates are 40, and 10. So we can say, let's say P equals to 40 and Q equals to 10. So there is your coordinates, 40 and 10. Think about that question, and the answer should be 0. So when you are done, make sure that your answer there is 0. So let's move on. Equation of a line. We have said that the two main areas is gradient, or the two main areas are gradient and equation of a straight line. So we are done with gradient. Then let's move on to equation of a straight line. With these two main areas and the equation of a straight line, we can be able to work out other minor areas. Therefore, equation of a line, or equation of a straight line. Remember, it's always a straight line, no curves here. So because we are dealing with straight lines, a line that doesn't have a curve. Therefore, whenever you see a straight line, know that you will be tested one of these few things here. Therefore, equation of a straight line. I've said that an equation is a statement equating two expressions, and a statement equating two expressions. For example, in finding the gradient, there was that equation that we are working with. The equation was gradient equals to the change in y all over the change in x. So, for example, the change in y was the value of y2 minus the value of y2 minus y1 all over x2 minus x1. So that is a form of equation. Now, when we talk about equation of a straight line, we'll just expound on this equation here. Yeah, it is a very simple equation, and I believe you have seen how we can use it to find gradient. Now, we are going to use this equation to find the equation of a straight line. We will just expound it. Therefore, I'll just need to have an example, then we can work on it. An example, find the equation. Find the equation of a straight line whose gradient is -4 and that passes through a point, or through the point P 2, 1. So find the equation of a straight line whose gradient is -4 and that passes through the point P 2, 1. This point 2, 1 has been you get the point P 2, 1 with the assistance of the y and the x coordinates. Okay, so that's how you get the points. Now we are going to use this equation to be able to find the equation of a straight line. Now, equation of a straight line can be written in the form of y equals to mx plus c. This is the general equation of a straight line, y equals to mx plus c. Therefore, how do we reach here? Yes, we will need to use this. What is our gradient? Our gradient is -4. Should be equals to y2 minus y1. Let's introduce a coordinate xy. And with this, we can be able to form the equation of a straight line in the form of y equals to mx plus c. So you have x minus, remember that an equation does have the x and the y's, as you can see. Therefore, that's the reason we are introducing these x and y. So x minus the coordinate of, so here we have y minus the coordinate on this point, the y coordinate on this point P. So y equals to, or -4 equals to y minus 1 all over x minus 2. So we are just expanding this equation. Yes, now using values that are known. Therefore, we cross multiply. I believe you know this art of cross multiplying. Always have your y on the left hand side. So we will start with y minus 1 equals to -4 into bracket x minus 2. Therefore, we can say that y minus 1 equals to -4x. -4 times -2 is +8. Our equation hasn't reached this point. You can see y must remain on the left hand side, and then all the other values on the right hand side. So we need to move this -1 to this right hand side to have y equals to -4x plus 8. This is -1. When you cross the equal sign to this side, it is +1. Therefore, your final product here will be -4x plus 9. And that is your equation of the straight line whose gradient is -4 and which pass through P to -1. The coordinates of P are 2 and 1. As you can note here, our m is a constant, and which is -4 here. Notice that -4 is the gradient. So the gradient can also be said to be m. So you have your m here, that is the gradient. So m is the gradient, -4. This I say because you'll find situations where you've been given the equation of a straight line, and you are required to find, you've been given the equation of a straight line, and you are supposed to find the gradient. Note that in this form, y equals to mx plus c, y remaining on the left hand side, and all the other values on the right hand side, m is the gradient. Okay? And don't make a mistake of saying -4x. So m is a constant, and that constant is the gradient. So should you be given this equation, you can be able to find the gradient. The gradient is -4. Well, that was not what we required. We just needed the equation of the straight line. So let's do another example. Let's try out another example here. Find the equation of the line passing through so find the equation passing through the points or the coordinates through the coordinates 2, 4, and 8, 7. 2, 4, and 8, 7. So this equation, we'll give it in the form of y equals to mx plus c, where y will remain on one side, while all the other values, the x's and the constants, on the right-hand side. Okay. Now, to form the equation of a straight line, as you have seen, we will require this simple equation, where we say that gradient, a new letter we have introduced here, m. M is the gradient. Why don't we use it? So we say that m equals to the change in the y coordinates to the change in the x coordinates. So y2 minus y1 all over x2 minus x1. Now, do we have the gradient? We lack the gradient. We just have two coordinates. We just have two coordinates, therefore you require to find the gradient. We have already worked on how to find the gradient. How do we find the gradient of these 2 points? So we can say gradient equals to the change in y all over the change in x. We are using this same formula. So we can choose 7 minus 4 all over 8 minus 2. 7 minus 4 is 3 all over 6. So 3 over 6, you simplify that, you get a half. So we can say that the gradient of the line that passes through the point 2, 4 and the point 8, 7 is a half. Now, for us to use this formula, we require two things. We just need the gradient, and as you can check this, we have it. It's a half. Then we also need 1 point on that line. In fact, we had 2 points. You can choose whichever, yes, you wish. Let me choose 2, 4. Yes, 1 point, let's say 2, 4. And then you have your gradient as a half. I also said that you introduce an x and a y coordinate, x and y as a coordinates for us to have an equation of a straight line. So we apply this, we have the gradient, it's a half, equals to, I've said we introduce a y, so y minus the y coordinate, or the y on this coordinate, so y minus 4 all over x minus 2. So cross multiplying this, and where the y remain on the left hand side, so we start with y, so 2 into bracket y minus 4 equals to 1 into bracket x minus 2. So open up this bracket, you have 2y minus 8 equals to 1 times x is x, 1 times negative 2 is negative 2. We want our equation in this form. Let's have the y remain on that side. So 2y equals to x minus 2. We have 8 coming on the right hand side, so plus 8. I believe you have followed up this. We can love that. So 2y equals to x minus 2. Let me write it here. 2y equals to x minus 2 plus 8. What is that? Minus 2 plus 8 equals to plus 6. Then we can divide here by 2, by 2, by 2. So we do this so that we have our equation in the form of y equals to mx plus c. So as you can see, you have your y equals to a half x, or x over 2, it's all the same, plus 6 divided by 2 is 3. So we can say, you can see your gradient remains a half. This half here, it's still here, a half. And then you have other values like c is a constant. You have your y there. You have your x following up the gradient. So that is the equation of a straight line passing through the coordinates 2, 4 and 8, 7. Why don't you try this? So write the equation of a line passing through the following pairs. So you have pairs here, 4, 5 and 10, 17. 4, 5 and 10, 17. You are finding the equation. So find the equation of straight lines, of a straight line with coordinates 4, 5 and 10, 17. So those who are fast, I believe you are done with that. Yes, but don't worry, if you have not finished, you still have time. So negative 1, negative 7. So negative 1 and negative 7. Another coordinate on this line is 5 and 23. Number C, you will do this, 3 and 10, 4 and 7. So these are the coordinates on these 3 lines. So you have a first line with 4, 5, 10, 17, second one and the third one. So you can do that. And I believe when you are done with this, you'll be good with finding the equation of a straight line. So remember, you have to find the gradient first. When you have the gradient, then remember that you need 2 things, the gradient and at one point on this straight line. When you have those 2 things, apply this formula that we had used in finding the gradient. When you are done with that, you can work out you can expound that equation to form the equation of a straight line. So remember that the topic we are covering today is equations of straight lines. It is covered in Form 2. We are live on YouTube and Facebook as well. Now, we had this equation y equals to mx plus c. We had the equation y equals to mx plus c, and we have said that m is the gradient and c is a constant. Well, you might not know the use of this constant c, and that is what I want to take you through. So another area we will cover is called the y and the x intercept. The y and the x intercept. Remember that we have dealt with the two main areas, the gradient and the equation of a straight line. With those two, you can see that we can be able to form the equation of a straight line into this form. And in that form, we can be able now to find, number one, y and x intercept. So when we talk about the y intercept, this is the point where your straight line crosses the y-axis. For example, let's have a sketch here, and you have your equation or your straight line cutting through the y-axis. So you have your y-axis, you have your x-axis. Now, we have said that the y-intercept is the point at which the straight line crosses your y-axis. So your y-axis there, you have your line, it crosses the y-axis at this point. Therefore, that is the y-intercept. Something you need to note is that the value of x at this line is always 0. Yes, the value of x at this point is 0. You can see that x proceed to 1, 2, -1, -2 in that order. At this point, the value of x is 0. Now, when finding the y-intercept, it is very easy for you to work out that. Yes? Beside the fact that c is the y-intercept, yes? When you are told to find the y-intercept, you can read it. You know that c. So c in this case, you have your equation y equals to mx plus c. We have said this is the gradient. Then this other constant here is the y-intercept. The y-intercept there. Let's take an example. We say that you have an equation y equals to mx plus c. Well, sorry. Your y is 2x minus 3. Your y is 2x minus 3. So note that your gradient, if you are required to find the gradient, your gradient here is 2. And then you have your c. C is the y-intercept. Yes, and you can see it's -3. That means your line is crossing the y-axis at -3. So if you have here 1, 2, 3, and that is -1, -2, -3. So your line is crossing the y-axis at -3. I don't know to which side. Yes? Well, there is an idea you can use to know which side your line head to. So you can have your line like that. And we can say that your line is crossing -3. Note that your x value is 0. And if you asked for the coordinates where your line crosses the y-axis, you'll notice that it is coordinates. Know that they are given as x and y. So the x value at this point is 0, while the y value is -3. Therefore, when you are asked for the y and the x intercept, for the y-intercept, it's very easy. For the y-intercept, it's very easy because you can just read it from your equation. It's -3. So C is the y-intercept. So C, which is the y-intercept, is, for that equation, -3. So we can say the coordinates where the straight line crosses the y-axis is, so for that equation there, it is 0, -3. 0, -3. You might forget about that. You might forget about this. If you don't remember that C is the y-intercept, you can find the y-intercept using another method. The same method you'll use to find the x-intercept. So you say that, note that at the y-axis, x is 0. And in fact, we call this line here x equals to 0 as well. Well, this one is y equals to 0. Note that. So we can say that at x equals to 0, what will be your y in this equation? So y equals to 2x minus 3. That is our equation. We chose that to use this. So y equals to 2x minus 3. We know that at y-axis, x equals to 0. So we can introduce 0. We substitute it here. We say that y equals to 2 into bracket 0 minus 3. Therefore, y value is -3. And as you can see, the y-intercept is -3. Now, if you asked for the x-intercept, so this is the y equals to -3. We have said that is the y-intercept. For the same equation, what is your x-intercept? The point at which your line passed through the x-axis. So your line passed through the x-axis at which point? We'll see. Yes? Let's find that. We have the equation equals to 2x minus 3. Now, at the point which your line passed through the x-axis, the value of y is 0. You can see that the value of y on this line is 0. Therefore, you equate y with 0. So 0 equals to 2x minus 3. So we take this -3 to that left-hand side in a way that we'll be having 3 equals to 2x. Note that this is a -3. When it crosses the side, you have 3. Now divide by 2, divide by 2. Therefore, your x value will be 3 all over 2. That is your x-intercept. Using this, you can be asked for the coordinate where the straight line crosses the y-axis. So the point where the straight line the straight line is given using the equation y equals to 2x minus 3. So the point where the straight line crosses the x-axis is, so it will cross the x-axis at 3 all over 2 comma 0. So that is the point where your straight line crosses the x-axis, and using these two, in fact, you can be able to draw the straight line accurately, because you know at which point your x-axis pass through, or at which point your straight line pass through the x-axis, and the same the point at which it passed through the y-axis. So those are the 2 points. And know that this y-intercept and the x-intercept, on average they can give you not less than 3 marks. So not less than 3 marks. Let's move on to the next idea. I'll just give you an example you try out. So find the y and the x-intercept. Find the y and the x-intercept in these equations. A. So find the x and y-intercept in the following. The following equations. The first equation here is y equals to 3x plus 1. Straight away you can be able to find the y-intercept. It's 1. Yes? But you can as well use this idea here of equating with 0. You find the y and the x-intercept. B is y equals to 2x minus 5. You try out that as well. C, you have y equals to 7x plus 4. D, y equals to 10x plus 5. Straight away you can be able to find the y-intercept. Don't forget that, because C is the, let me give you a hint here. C is the y-intercept. The point at which your straight line crosses through the y-axis. Moving on, I want us to think about the perpendicular lines. The perpendicular lines. So perpendicular lines being formed by two straight lines. Know that a line that forms an angle of 90 degrees with another one it's referred to as they are referred to as perpendicular. Therefore, there is that relationship between two perpendicular lines, or two perpendicular straight lines. It's a relation that I would hate to find you forgetting, because it's a very simple one. So perpendicular lines. So we say for perpendicular lines, when we talk about perpendicular lines, these are lines that meet at an angle of 90 degrees. So for perpendicular lines, we say that the gradient of the first line, we can say that L1, L2, the gradient of the first line times the gradient of the second one equals to -1. So using this relationship, you can be able to find an equation given another one. So m1 times m2 equals to -1. M here is the gradient, don't forget that. This is the gradient of the first line. And then you have the gradient of the second one. When you multiply them, you get -1. For example, so you have an example here. Example, we say that find the equation of the line that passes through the point 1, 2, and is perpendicular to y equals to x plus 1. Y equals to x plus 1. We are supposed to find the equation of the line that passes through the point 1, 2. Let's say this is our first line with a point 1, 2 somewhere. Okay, 1, 2, as you can see there. It is perpendicular to another line with the equation. So this is the other line. It has the equation y equals to x plus 1. Now, note that for us to find the equation of this first line, you need to have two things. You need to have the gradient of that line and this one point. At this point, now we do not have the gradient. We do not have the gradient. Now we need to find it. Yes? We know that the gradient of the first line times the gradient of the second one give us -1. What is the gradient of the first line or the second line? Well, you have been given the equation y equals to x plus 1, and therefore you can come up with the gradient of this line right away, because we know that it is in the form of mx plus c. M here is 1. Remember that 1 times x is x. So our m is 1, and let us call it m1 or m2, represented by line L2. So we say m2 equals to 1, and then using the relationship between two perpendicular line, m1 times m2, which equals to -1, we can come up with the gradient of the first one. So m1. So we say m1 times 1 equals to -2. We have said that m2 is 1. So m1 times 1 equals to -2. So we can say m1 equals to, we divide by 1, we divide by 1 here. So, sorry, here it's -1. So m1 times 1 equals to -1. So m1 equals to, you divide by 1, you divide by 1. So you have -1. Okay? So that is your gradient of the first line. Now with the gradient and with the point, you can come up with the equation of a straight line. We are going to use the equation y equals to y2 minus y1. So gradient equals to y2 minus y1 all over x2 minus x1. So you have your gradient ready. Gradient is -1 equals to, you introduce y, you subtract y, that point on the first line, so y minus 2 all over x minus 1. So let your y be on this side equals to, we are cross multiplying, negative 1 times x is negative x, negative 1 times 1 is 1. So y equals to negative x. Let your negative 2 cross the side to your right hand side for you to have plus 1 plus 1 plus 2, sorry. So in a way that your equation will be negative 1x or negative x plus 3. That is the equation of the perpendicular line that the equation of your perpendicular line or your line that crosses or that form an angle of 90 degrees with the other line. Therefore, learner, you need to work out examples. I always advise students to practice more. We have dealt with this. In 1 week time, you might forget about it. So therefore, try your level best to keep on practicing the concepts that you have learned. And in doing so, you will have a great time when it comes to such topics. Okay? So the only area we have not dealt with is the parallel lines. That is even simpler compared to that of the perpendicular line. So I'll give you a challenge to explore that sub area or subtopic using the concepts which are somehow related to that of perpendicular lines. So I wish you all the best as you do your revision on such topics and other related topics. So have a great time.